Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 39, combination sum, and it's quite wordy as you can see. Now, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as we can see, we're given an array of distinct integers called candidates. And we also have a target number, and we gotta return a list of unique combinations of the candidates where the chosen numbers sum to the target. Now, what does this even mean? Let's check our examples here to actually understand it better. As you can see, we're given this array here that has 2, 3, 6, 7 inside of it, and this is called candidates. And our target is 7. In the output, we've returned 2, 2, 3, and then 7 as well. Why? Well, the sum of these three numbers is going to be equal to 7, which is our target number here. And this number by itself is also equal to our target number. So this is what we're doing. We got to find the sum of the numbers that can actually be equal to our target number. And as you can see, we only have 1, 2 here, but we've used 2 twice. And even if we check this example here, our candidates are 2, 3, 5, and our target is 8. And as you can see, we've returned these. We've used 2 4 times, and then we have 2, 3, 3. So we used 3 2 times, and we also have 3 and 5. And the sum of all of these individually are going to be equal to 8, which is our target number. Now, how are we going to actually solve this? Well, I'm glad you asked. This is our candidates array and this is our target number. Now, let's solve this together, and I want to finish this video until I make sure you fully understand how to solve this problem once and for all. Now, we saw in the examples that, for example, we used 2 a bunch of times or we used 3 a bunch of times. So this kind of gives us a hint that we've actually explored all of the possible combinations. That's why we know how many 2s we should use or how many 3s we should use or how many combinations of a bunch of 2s or 3s we should actually use. So because we know we need to explore all of the possible combinations, we need to use backtracking. Now I'll take these 2 here so we can actually have some space because I'll visualize the whole decision tree. Since we're going to use backtracking, we're going to have a decision tree, but we have to have the correct logic behind it. I'm going to show you the tree, and then slowly as we actually start expanding the tree, I'll explain you the logic because it's going to help with the visualization. So as you can see, we have an empty array in the beginning, and this is going to be our result array. Now we're going to explore all of the possible solutions. So we're going to be like, all right, let's see what will happen if we start with 2. Let's see what will happen if we start with 3. Let's see what will happen if we start with 6. Let's see what will happen if we start with 7. Why? Because these are the numbers inside of our candidates array, and we're checking what will happen if we start with each one of these numbers here. Now we're going to check if this number is equal to our target number, which is 7. So is 2 equal to 7? It's not. So we're going to keep on expanding this one, and we're going to be like, all right, we've added 2. Let's see what else we can actually add to it. We're going to be like, all right, let's add another 2, or we could actually add a 3 to this one because this is 2 and then we add a 3 to it, or we could actually add a 6 to it, or even a 7. And then here we're going to look for answers again. We're going to ask, is 2 plus 2 equal to 7? Is 2 plus 3 equal to 7? If they are, we're going to add it to our result. If they're not, we're going to keep on expanding. And as you can see, these 2 numbers, 2 plus 6 is 8 and 2 plus 7 is 9. So these 2 are greater than our target number, and they're not going to be valid answers. So we're not going to keep on expanding and actually checking them further because we know they're already bigger than our target number. So even if we expand, we're not going to find an answer. So we're going to actually ignore these. Then we're going to come here and we're going to be like, is 3 equal to our target number, which is 7? Not really. So we have to expand this one. When we expand, we're going to ignore the previous numbers before 3. Why? Because this is going to prevent having duplicate inside of our tree. Because if we actually add the possibility of having 3 and 2, that's going to be basically exactly like this one, and that's going to cause a duplicate. We are already exploring the combination of 2 and 3. 2 and 3 or 3 and 2 are both equal, and the question doesn't allow us to have that kind of duplicates. Because we're not looking for permutations, we're looking for combinations. And because of that, we're going to ignore the numbers before 3, and that's going to be 2. And we're going to be like, all right, we can actually check 3 with 3, and 3 with 6, and 3 with 7. And again, don't worry, when we actually explore more, you're going to get this more intuitively. So 3 and 3, 3 and 6, and 3 and 7. We're going to be like, is the sum of this equal to our target number? Well, the sum of this is 6 and our target number is 7. So this is smaller than our target number. So we have to explore and expand this one further. Let's check this one. Is the sum of 3 and 6 equal to our target number? Well, the sum of 3 and 6 is gonna be 9, and that's gonna be greater than our target number, so we're gonna ignore this one. And same thing for this one here, so these two are gonna get ignored. Now we're gonna explore this one and we're gonna ask if the current number that we have here is equal to our target number. Well, 6 is not equal to our target number, so we have to explore and expand this one as well. But when we actually expand this one, we're gonna ignore all of the numbers that come before it because we don't wanna have duplicates. So we're gonna be like, what if we test 6 with 6, and what if we test 6 with 7, like so. And if we check, 6 plus 6 is gonna be greater than our target, and 6 plus 7 is also gonna be greater than our target, so these are gonna get ignored. Now we're gonna explore this one and we're gonna be like, is this equal to our target number? Well, yeah, 7 is equal to 7, so this is gonna be one of our answers. Now I'm gonna change the spacing here so we can actually have more space to expand these further, and we're gonna ignore 6 entirely, like so. As you can see, we have 7, we have 3, we have 2. Now let's come here and explore this one. We're gonna be like, is 2 plus 2 equal to our target number? Nope. 2 plus 2 is 4, and our target number is 7. So let's keep on exploring. Let's expand this one, but we're gonna say that we're gonna ignore all of the numbers that come before 2, but there are no numbers that come before 2. So we're gonna be like, all right, let's test it with 2, let's test it with 3, let's test it with 6, let's test it with 7. Now we're gonna be like, is 2 plus 2 plus 2 equal to our target? Well, the sum of this is gonna be 6, and our target is 7. So the sum is actually smaller than our target, so you have to explore further. If we check this one, 2 plus 2 plus 3 is actually equal to our target, so this is gonna be one of our answers as well. Let's check this one, 2 plus 2 plus 6, that's gonna be 10, and that's gonna be greater than our target, so we're gonna ignore this one. And 2 plus 2 plus 7 is also greater than our target, so we're gonna ignore this one as well, like so. So let's ignore them, and let's bring this here so we can actually have more space. Now let's explore this one. Let's get it here, and we're gonna be like, all right, the last number that we added to this was 3, so we can't add any of the numbers that come before 3. So we're gonna be like, the options that we have are gonna be 2, 3, and 3 itself, 2, 3, and 6, 2, 3, and 7, like so. And then we're gonna be like, do you have an answer here? Well, 2 plus 3 plus 3 is gonna give us 8, so this is gonna be greater than our target, and we don't want it. And same thing for this one and this one. The sum of all of these are gonna be greater than our target, so we're gonna ignore them entirely, like so. And then we're gonna expand this one. We're gonna be like, is 3 plus 3 equal to our target? Not really, this is 6 and our target is 7. So let's expand this. We're gonna be like, all right, we're currently at 3, so we can't add any other number that come before 3. So let's add 3 and 6 and 7. 3, 6, 7, like so. And if we check, the sum of this is gonna be 9, which is greater than our target. And same thing for these two, so we're gonna ignore them entirely. Now I'll bring this here so we can actually expand this one further. So we know 2 plus 2 plus 2 is not equal to our target, but it is smaller than our target, so we have to expand it further. And the last number that we added was 2, so we're gonna be like, we can't add any numbers that come before 2 inside of our candidates array. Well, would you look at that? We have no numbers that come before 2, so we're gonna be like, all right, let's add another 2, another 3, another 6, and another 7. So we've added 2, 3, 6, 7. And if we check, the sum of all of these are gonna be greater than our target, so these are all gonna get ignored. And these two are gonna be our answers. Now let's code this in the simplest way possible. Alrighty, so first of all, I think we can all agree that we need to return something, right? So let's define a result variable, and this is gonna be equal to an empty array, and we're gonna return this at the end. Then we're gonna define our backtracking function, and I'll just call it backtrack. And this is gonna take a bunch of inputs. The first thing is gonna be remaining, and this is gonna tell us if our sum is equal to our target number, or we're greater than our target number, or if we're actually smaller than our target number. So this is what remaining is doing. Then we're gonna have another variable called start, and this is gonna tell us which part of the candidates array we can use, just like we saw on the slides, because we were not allowed to use all of the numbers because we wanted to avoid duplicates. And then the last thing is gonna be a path array, and this is gonna contain the answer that we found. For example, if our answer was like 2, 2, 3, path is gonna have this inside of it, so we actually know what's our answer. So this is literally the path we took to get to our answer. So here, when we actually find our answer, meaning when our remaining is equal to 0, so when we actually reached our target number, we wanna add our path array here to our result. So we're gonna say result dot push of path, like so. And then we're gonna be like, else if, because we had multiple occurrences that we actually were bigger than our target number, like our sum was greater than our target number. So we're gonna be like, if remaining is smaller than 0, meaning if it is negative, meaning if we are actually greater than our target number, we just want to return because we know we don't have an answer, so we just want to ignore it. Then below this, we're going to have a for loop that says for let I, and I is going to be equal to start, and we want to keep on looping as long as I is smaller than candidates dot length, and we want to keep on incrementing I on each round. Then we're going to get inside of this one. Here we're going to literally do what we saw in the slides. We're going to be like, what will happen if we start from 2? What will happen if we start from 3? What will happen if we start from 6? And what will happen if we start from 7? So for doing this, we're going to be like path.push candidates at the index of I. And this is basically saying that we're going to add 2 to our path, and then 3, and then 6, and then 7. Each time we add it, we want to call our backtracking function to check if we're going to find an answer. So we're going to be like, all right, we've added a candidate to our path. Let's explore that path and see if we're going to find an answer. The first thing that we got to pass to our backtracking function is remaining. So we're going to be like remaining, whatever remains to get to the target is going to be equal to remaining minus candidates at the index of I. Why? Because for example, if we have 5 remaining to our answer, we just added another candidate to our path. So we got to subtract that and see if we're going to reach our target or not. And then we have to actually give it the start, and this is going to be I. And then we have to pass it this modified path that we have here. So we're going to be like path. Then below this, we got to actually pop the candidate that we added. So we actually added it, and then we call this function to check for the answers. And now we're going to be like path.pop. And this is going to basically pop this number that we added. So we can move to the next round and actually check with the next candidate. And this is going to be our backtracking function. Now let's call it, we're going to be like backtrack. We're going to start when our remaining is going to be target. For example, if our target is 7, our remaining is going to be our target because we've not actually added any numbers to our path. And our start is going to be 0 because we're going to start from the index of 0 in our candidates array. And our path is going to be an empty array in the beginning. And then when this is done, our result array is going to be filled with answers, and we're going to return it at the end. But when we actually push our path to our result, we got to make a copy of it and not push it directly. And for doing this, I'm going to do this basically, and this is going to push our path array to our result as a copy. Now, if we run our function here, we're going to see if we're going to pass our tests or not. Moment of truth. Yep, as you can see, all 3 of them are passed. Now let's submit it and see if we're gonna get accepted. Yep, as you can see, we got accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.